Hello, geometry folks. We are going to do a video about the area of a triangle. Now, you might be thinking, why am I doing the area of a triangle? I've already done that before. It's 1/2 base times height. And you're absolutely right. But in fact, there are lots of area formulas for a triangle because you don't always have the base and the height. You might have other stuff. And that's what we're going to look at today. All right. So if I come down here and I look at this thing that says opening exercise, it says you've got 3 triangles, determine the areas for each. If it's not possible, describe what's needed in order to determine the area. Okay, fine. So if I look at triangle number 1 right here, we just said that the area of a triangle is 1/2 base times height. And so in triangle number 1, my base is 5 and my height is 12. And so 1/2 of 5 times 12 is going to be 30. Done. Let's look at triangle number 2. Well, in triangle number 2, I'm going to assume this 20 is this entire length, okay? And this 8 is the height. So the area of this triangle would be 1/2 8 times 20, and that's going to be 80. And then last but not least, I have GHI. I have the 12 and the 15, but the 12 this time, is not the height. That's a side of the triangle, but it's not the height. If you want the height, you need to know this distance right here. You need to know the length of that altitude, and we do not know what that is. Okay, so what else do we need? I need to know the height. Okay, so I would need a way to find out what that height is. All right, so let's come down here. And it says the area of a triangle is 1/2 BH. Okay, 1/2 BH. Whereas until today, you needed an altitude to be able to use this formula, right? The altitude's the height. Time to explore another option. Okay, fine. What option do they want us to look at? It says express sine C as a ratio in terms of H and A. Okay, well, C is right here. And the sine of C, well, sine would be opposite over hypotenuse. So in the right triangle that includes C, the opposite is H and the hypotenuse is A. Okay. Then it says solve your result from part A for H. All right, so that means solve for H means get H alone. So I'm going to multiply both sides by A so that I can get the H alone. And H equals A sine C. And then it says substitute your result for part B into the area formula. So my area formula is 1/2 BH. And we just said that H is A sine C. So 1/2 B times A sine C. And we just ended up with A equals 1/2 AB sine C if I write it alphabetically. Well, what does that mean? Here's what that means. If I come back up here to this picture, okay, and I have an A here, and I have a B here, and I have this angle, if I want to find the area of this triangle, I don't need to actually have the height. I can use side A, side B, and angle C, plug them all into this formula, and get the area of a triangle. Okay, what is the relationship between the angle used and the sides? Well, if I look at A, B, and C, A and B are flanking C. C is the included angle. Okay. Now, after all of that, what I've done is I have proved that 1/2 base times height is equivalent to 1/2 AB sine C. Okay. That proof isn't something that I'm going to ask you to replicate, but I want you to know that this formula that we're about to use did not just come out of thin air. It came from trigonometry. Okay. But what I really need you to know is I need you to know the formula and how to use it. So let's try that out now. All right. The area of a triangle given SAS, meaning you have two sides and the angle in between. The area of a triangle given SAS is 1/2 AB sine C, where A and B are two of the sides and C is the included angle, the angle between them. It does not have to be an A and a B and a C. It just needs to be, in shorter terms here, the area is 1/2 side 1 times side 2. Whoops. Side 1 times side 2 times the sine of the angle between. Okay? That's really what that formula says. Let's do it. I look at number 1. I got a 21-degree angle, a 9 side, a 12 side. If I want the area of this triangle, the area of a triangle is 1/2 AB sine C. Area is 1/2 side 1, side 2, times the sine of the angle between them. Doesn't matter which side you use first. This is multiplication, so it's commutative. I could do 1/2 12 times 9 times the sine of 21. It's all the same thing. And then I'm just going to throw it into the calculator. So the area of this triangle is 1/2 times 9 times 12 times the sine of 21. As soon as my calculator decides to load. I thought if I sang a song, it would go faster. Oh, there we go. All right, so I am going to add a calculator page here and do 0.5 times 9 times 12 times the sine of the angle in between, which is 21. And this is just a fun fact for those of you using a calculator at home. I'm noticing in this top right-hand corner, it says rad. I don't want to be in radians, so I'm going to hit doc 7 2 and then change radians to degrees and hit OK. There we go. Now it says degrees, and I will get the right answer. 19.3519. And it says nearest tenth, so that's going to be 19.4 is the area of that triangle. Okay, let's do it again for number 2. So on number 2, I've got a 6.5, a 55, and an 8. I have two sides, and the angle in between. The area of a triangle is just 1/2 side 1 times side 2 times the sine of the angle in between. And then we're going to type that into the calculator. 0.5 times 6.5 times 8 times, what was that angle? 55. Times the sine of 55. 21.298. And that's going to be 21.3 to the nearest tenth. Da-da-da. And then the area of a triangle down here. Okay, so I have a side, I have another side, so I need the angle in between. Uh-oh. I don't have the angle in between. How am I going to get that? Well, wait a minute. I know that this is 75 and that's 45. So 75 plus 45, that's going to be 120, which means this is a 60-degree angle. Okay, now I have what I need. The area of a triangle is 1/2 one side times the other side times the sine of the angle in between. And you might be thinking, oh God, that other side, it's 6 plus 6 radical 3. I don't care. I'm just putting it in the calculator anyway. So if I want to find the area of this, I'm going to type that in. 1/2 of 12 times 6 plus 6 root 3 sine 60. Okay, so 1/2 times 12 times 6 plus 6 root 3 times the sine of 60. 85.176, so that's going to be 85.2. And that's it, folks. That's the area of a triangle formula. Okay? Now on the back, we're just going to do a couple more of these, but you just have to remember, anytime you're going to do the area of a triangle, you need a side, another side, and the angle in between them. But what if I didn't give you a picture? Okay, just draw it. So it says find the area of triangle ABC if A is 6, B is 7, and sine C is 1/3. Okay, well, I'm going to draw the picture. So I have A, B, C. Little a equals 6 means the side across from a is 6. Little b equals 7 means the side across from or opposite b is 7. And they tell me for angle C, the sine of this angle is a third. Well, the area of a triangle is 1/2 a side times another side times the sine of the angle in between. And instead of giving us the angle this time, they did a weird thing and told us what the sine of the angle is. I mean, okay, if that's what you want to do, fine. And now I'm just going to type this into my calculator. And I'm going to do this one in my head. 1/2 times 6 is 3. 3 times a third is 1. 1 times 7 is 7. The area of that triangle is 7. Find the area of an isosceles triangle. Okay, so isosceles, 2 equal sides. If the measure of the base angle, so that would be 75, and in an isosceles, the other one would have to be also, and each leg, the legs of an isosceles are the equal ones, is 10. So I've got 75, 75, 10, 10. If I want the area of this triangle, I have a side, another side. I would really like the angle in between. So 75 plus 75 is 150, meaning this is 30 degrees in between. So the area here is going to be 1/2 side, side, sine of the angle in between. So 1/2 10 times 10 times sine 30, 0.5 times 10 times 10 times sine 30, and you get 25. In rhombus stew, ST is 8, and angle STE is 30. Find the area of the rhombus. I thought this video was about the area of a triangle. It is. So if I want the area of a rhombus, I better make some triangles pretty quick. How about I do this? Bing! Now I got a triangle. And if this is a rhombus has 4 congruent sides. So if that's 8, that's 8, that's 8, that's 8. And if this is a rhombus, opposite angles are congruent. So really, these are just 2 triangles smashed together. So if I want the area, I can do 1/2 AB sine C, and then multiply that by 2. And you might be thinking, well, then why not just not multiply it by 1/2? You're totally right. This 1/2 and this 2 effectively cancel each other out. So I have 8 times 8 times the sine of 30, so that's going to be 64 times sine 30, and that should be 32. Last one. The area of ABC is 34. Find the angle. Ooh, okay. Well, if I wanted the area, I would have this and this, and I don't know the angle. So I know 1/2 AB sine C equals the area, and the area is 34. So if I want to solve for x, I need to get rid of everything else. So let's see, 1/2 times 8 times 9. 8 times 9 is 72. 1/2 of that would be 36. So 36 sine x equals 34. If I need to solve for x, I've got to divide by 36. So sine x equals 34 over 36. And I still need to get x alone, so I need to get rid of sine, which means I need to take the inverse sine of both sides. And remember, anytime you need an angle, you need to use an inverse trig function to get it. And now I just need to do inverse sine 34 over 36. Inverse sine 34 divided by 36 is 70.8. And it says to the nearest degree, so 70.8 is going to be 71 degrees. That is it, my friends. That is the area of a triangle. Make sure you know how to use it. The area of a triangle is 1/2 AB sine C, where A and B are 2 of the sides, and C is the angle in between them. I hope that makes sense. I hope you have a good day, and I hope You have a good night too. See ya.